Okay chaps, hello, 7.6. We're actually going to solve inequalities as if they were little equations. It says solve these inequalities, page 99, grade C straight away. I've got here 1a, 3x minus 2 is greater or equal to 4. Minus 2, take it over and plus it. 3x greater or equal to 6. Divide by 3, x, oh dear, what am there? Getting all laggy and silly. Divide by 3, x is greater or equal to 6 divided by 3, 2. Easy. Let me go and do D now. I've got 5 plus 2p is greater than 1. Take the 5 over and minus it. 2p has got to be greater than 1 take away 5, minus 4. P has got to be greater than minus 4 divided by 2, minus 2. So if p is greater than minus 2 and you substitute it in there, then the answer you get on the left hand side will be greater than minus 1. That's basically how your brain should recognise it and see it. And the last one says 5 is greater than 13 minus x. Now nobody likes minus x's, trust me, so you bring the minus x over and plus it. So 5 plus x has got to be greater than 13. I moved it over just like we're doing an equation. Now I can get rid of my 5. 13 take away 5. Leaves me with x is greater than 13 take away the 5. I'm showing you all my steps now. X has got to be greater than, I don't know what that is, 8, 9, I haven't got a clue, tired, 8, yeah. 8 has got to be greater than 8. And let me just prove to you that this actually does make sense. So let's just change colour. Give me a number greater than 8, e.g. x equals 9. If I put the 9 inside there, what do I get? I end up with 5 is greater than 13 take away 9. 5 is greater than, what is 13 take away 9? 4. Is 5 greater than 4? So it's true. So this works, doesn't it? Alright, that's how you can test yourself. Right, that's that one. Question 2. I really like this kind of thing. They're quite pleasant. It says list all the integer values of n such that, here we go, such that. Let's just get the inequality down there. I like these little sandwiches. There you go. I've got to list all the integer values such that minus 3 less than n less than 4. All the whole number values that could be negative or positive that fit this inequality. Well, minus 3 is less than n, so I've got to start at minus 2, minus 1, 0, 1, 2, 3, and stop, because it says n's got to be less than 4. So you traditionally put these in a little squiggly bracket like that. Old-fashioned style maths there, but never mind. That's how it goes. Pick another one. Let's go for D. It says minus 2 is less than or equal to n, and that's going to be less than or equal to 1. So I'm allowed to be minus 2 because it says so. It says equal to. So I'm going minus 2, minus 1, 0. Am I allowed to be equal to 1? Yes, I am. N's got to be less than or equal to 1. So 1's allowed. Put in a beautiful little squiggly bracket. Looks ever so stylish. It'll impress the examiner. Probably give me a little laugh. Ha ha ha. This is a really young guy. It's not marked before. Right, F is a bit of a new thing. Minus 4 is less than 2n. Now don't start crying. And that's got to be less than or equal to 6. Well, look, it says 2n there. If I divide both sides by 2, I'll get a little n in the middle. Right, so halve it all the way through. 6 divided by 2 is 3. 4 divided by 2 is 2. So it's negative 2. Alright? So what I basically did was just to divide by 2 on both sides, so reduce it down to n. So minus 2 is less than n. So I can't be minus 2. I've got to be minus 1, 0, 1, 2, and I'm allowed to be 3 as it says so. Squiggly bracket. Let's do the last one. It says here minus 5. It's got to be less than or, I can't see, yeah, less than or equal to 5 lots of n, and that's got to be less than or equal to 8. Right, let's divide by 5 on each side. So there we go, divide by 5. What do we get? 5 divided by 5 is 1, so minus 1 is less than or equal to n, and 8 divided by 5 is what? 1 3/5. Let's study this one carefully. Yellow, that means getting serious. Am I allowed to be equal to minus 1? Because it says minus 1 is less than or equal to n, so yeah. I could be minus 1, I could be 0. Now, what number, which is whole, is less than 1 3/5? The answer, 1 alone. Okay, n has got to be less than or equal to 1 3/5, but I want integer values, in other words, whole numbers. Alright, integer values, whole numbers only. So, minus 1, 0 and 1 fit quite nicely in that gap there, and I'm definitely less than 1 3/5. That's the last one, and I think I do question 3 as well, and on the other page it says find the largest integer that satisfies the inequality 5 minus 2x is greater or equal to 1. Let me give you that English again. Find the largest integer that satisfies the inequality 5 minus 2x is greater or equal to 1. Essentially, work it out, but give me the biggest value of x I'm allowed to be. Now, we do not, trust me, you do not want to work with negative values in front of the x when playing with inequalities. Don't even do that. It's better just to do this. We can say 5 minus 1, I brought this over and minused it, is greater or equal to, minus 2x becomes 2x, isn't it? I could do 5 take away 1 is 4, can't I? 4 is greater or equal to 2x. Let's write it round the other way because we're reading the wrong way, aren't we? So 2x has got to be less than or equal to 4. Is that alright? If 4 is bigger than 2x, 2x is less than 4. Okay. Now I can just divide by 2. Less than or equal to 4 divided by 2. So x has got to be less than or equal to 2. So how big can I go? Answer 2. What is the largest integer that satisfies the inequality? I'm allowed to be equal to 2 or less than it. Therefore, biggest value x is 2. There's no point saying, well, I'm allowed to be less than 2. I think I'll call myself minus 27. No good. Biggest value is up to 2. And I think I'll do number 4 as well because it looks really dangerous. Find the smallest integer value that satisfies the inequality this. So look for the smallest one permissible. Very dangerous. I've got brackets and all sorts. Alright. First thing, let's just bust it all open. 7 is less than 3, sorry, not 3x, I'm multiplying it, aren't I? Getting tired. Right, 3 times 2, 6x. 3 times 9, 27. Alright, I can take the 27 over and minus it. So 7 take away 27, it's got to be less than 6x. Well, that comes to minus 20, doesn't it? It's less than 6x. Let's write it round the other way. So 6x, if it's this way you read it as minus, this way you read it as plus. Sorry, this way you read it as less than, this way you read it as greater than. So 6x is greater than minus 20. Let's flip it over. Now I can divide by 6 the normal way. X has got to be greater than minus 20 over 6. So x has got to be greater than, 6 goes into there 3 times, and 2 left over, I believe, and 2/6, otherwise known as 3 1/3. And of course it's negative because it says so there. Now let's go for yellow because I want to reach the punchline. X has got to be greater than minus 3 1/3. Right, so whole numbers only. You want an integer value. So climbing up from minus 3 1/3, the next whole number I meet is minus 3. So x has got to be bigger or equal to minus 3. Is that okay? If I've gone bigger than minus 3, then bigger than minus 3 is something less negative than minus 3. So what is the best answer? Minimum answer is going to be minus 3. And there it is. That is an integer for you, and that's it. I'll stop now. I think we've got enough. I've done some of the really dodgy ones, and I'll be looking at the assess very shortly to see if it's worth our while. Alright, so you study that.